Welcome everyone in this video lecture session on 8051 microcontroller assembly language programming. It is pleasure to inform you that in two previous lecture sessions, we have covered the 8051 microcontroller architecture and right selection of a microcontroller unit from many variants. 8051 CPU registers, the RAM memory allocation technique, the special function registers were discussed in second lecture session. To address the huge request from the e-learner, the length of the second video lecture, that is lesson 2, that was further reduced and that is released with lesson 2.1. Today we are going to discuss about the most awaited part of 8051 microcontroller. Yes, that is assembly language programming. This is the introductory part and knowledge may be further extended to the next video lecture sessions. Upon completion of this course, you will be able to write the code using assembly language instructions. You'll be able to assemble and run an 8051 program. You'll be able to examine the program which is written inside the RAM code, byte by byte. You'll be able to write the stack associated programs. So this is the outline of the discussion. I've oriented the course in this way. First, the structure of the assembly language program will be discussed, followed by the program assembling and running with 8051 microcontroller, the execution of a particular program byte by byte, then programming with the stacks that will be discussed. Let us start with the very basic instruction, that is move. So move destination, comma source, it will copy the content from source to destination. You will see the instruction move a comma hash 55 hex. So here it is the immediate data. It will load inside the accumulator. So hash signifies that this is the value. So immediate data will be loaded inside the accumulator. But here is no such MVI instruction to specify that is the immediate data, as in case of your microprocessor 8085. So all the instruction will be of MOV. So whether it is the data means direct data or the data which is coming from any address or any register, all the instructions will be of your move instruction. Like the second instruction, move R0A, move R1A, that means from the accumulator, we can copy the content to any register R0, R1, R2. So all these registers like R0, R1 and R2, all are the register coming from the bank and it is under the RAM memory location, which is specified by the manufacturer. Okay. So in the next example, we can show you that the move a comma hash 23 hex. Actually, if I by mistake I am not placing the hash symbol, that means it will not be treated as your immediate data now. So hash without the hash symbol, what is the or the instruction we're writing that move a only 23 hex. So it will be treated as the address, means from this location the data will be copied inside the accumulator. Okay. So if I place one hash symbol, that means it will be the immediate data. Or if I am not specifying this hash symbol, then it will be treated as the address location from where the data will be copied inside the accumulator. Next instruction is move R5 comma hash 05F9. This 0 indicates it is the hex number. Means if it is the hex number, it is not the later. Okay. So instead of writing the instruction, if we are writing like F9, so F will be treated as your later. Okay. So it is not, it is a valid instruction. So 0, whenever it is finding the value F9 distributed by 10, then it will be treated as the data F9 and F will be treated as your hex number. It is not a letter. Okay. So other format is that move a comma hash 5. The result will be, means accumulator will be loaded with the value 05. Whether I am specifying 05 or 5, so it will be treated as your 05. So it is one valid instruction. But see that this instruction is not valid. Move a comma hash 7F2. And 7F2, it is, I mean, the value of this means 7F2, it is greater than the value FF. It is the maximum value it can contain inside the accumulator. Now the another instruction is add instruction. This is also one very commonly used instruction for addition. Add a comma source. So it will add the source operand to the accumulator. So add instruction directs the CPU to add the source byte to the register array and put the result inside the accumulator. Source operand may be any register or any immediate data or any location which contains the data, but the destination must be always the accumulator. Okay. So the instruction like add R4A or add R2 comma hash 1 to hash, these are the invalid instructions, because here is the destination must be always accumulator, but here we are not finding that the destination is your accumulator. Okay, so these are the invalid instructions. After that, you see that one very simple example we have considered to show that how the addition operation is performed. Move A, the immediate data 25, means the 25 is loaded inside the accumulator. Then it will execute the instruction move R2, then 34X, means 34 will be loaded inside the register R2. Then I'm writing add A, R2 means what is the value stored inside the register R2 that will be added with the accumulator. Then the result will be placed inside the accumulator. Okay, so we can reduce the number of instructions because there is no hidden pass tool that I have to write the program in this way. So there are several ways we can follow to write the same program depending on the register used. Okay, so I can write the instruction, the same program I can write. So move A, comma 25 hash means 25 will be loaded as it is immediate data. It will be loaded inside the accumulator. After that, it will execute the instruction add A, comma 34 hex. Means 34 hex is now the immediate data, and it will be added with the value which is stored previously inside the accumulator, and the result will be stored in the accumulator. So the result, what is the result inside the accumulator? It will be 25 plus 34x. Okay. Let us consider the structure of the assembly language program. You see that an assembly language instruction consists of 4 different fields. One is level, second one is mnemonics, which is tagged with the operands, and the command lines. So here we have considered one simple program. If you are writing the program using the pen and paper, then you should write starting from this instruction move R5, comma hash 25x, and up to here, then SM here. So the lines that we are finding from this program, that org000 hex and the end, actually these are the software directives. Is whenever I'm trying to burn the program inside the ROM memory of the microcontroller, then I have to go through this program. I have to write these 2 lines to start at this location 000 hex and end of a program, because there is no such instruction which is available inside the 8051 microcontroller instruction set. That is org00 means origin 0000 hex and the end. Actually, it is the software directives. Then the mnemonics. This is the mnemonics, which is tagged with the operands, and after that you see that these command lines after the semicolon, the lines will not be executed by the 8051 microcontroller. Okay. Now the different steps involved to write the assembly language program. First of all, you have to open one blank notepad. Okay. After that, you will have to write the program, then save the file with the file name with the file name along with the extension name .asm. Okay. So .asm is now the source file which is fed to an 8051 microcontroller assembler, which will produce the list file. Say for an example, we are considering myfile.asm. So the list file will be myfile.lst along with myfile.obj. This is the object file. So along with the other object file, my generated object file will be the input of the linker program. So it will generate the absolute file .abs, which is the input of the OH program. OH program will convert the corresponding hex file, because whatever the program we're writing, we're using the assembly level language or the high level language, ultimately you have to generate the missing level language consisting of zeros and ones, because microcontroller will understand only zeros and ones. It will not understand the assembly language program. It will not understand the C program, C++, Java. So in this process, we have to, means we are going through the assembler, we are going through the linker program, so that we shall have to generate the hex file. And now it is ready to run in the memory of the microcontroller chip. Okay. So this is one program that we have considered, and the byte by byte instruction that is written inside the memory location, that will be discussed. Now, we shall examine that the list file which is depicted over here of the sample program and how the code is placed in the RAM memory of the 8085 microcontroller chip. So that will be discussed here. You know that the microcontroller provides the ROM memory to write the program. I mean, I can run the program inside the ROM memory of the microcontroller. Okay, so when the microcontroller is powered up, the program counter has the value of 0000 in it. So therefore, it is always expected that the first opcode to be stored at the ROM address location 0000 hex. So for this reason, the first opcode must be born into the memory location 000 hex of the program ROM memory. Okay, so program counter is playing an important role in fetching and executing the program. So here is the program. You see that the assembly language program is given over here. So whenever the programmer means whenever we are writing the program using pen and paper, we shall write up to this one. Okay, so this one is sufficient. So here the program means it is actually the program of addition of 3 bytes of the data. So first byte is loaded inside the register R5 with this instruction. After that 34 is loaded in the register R7. Then with this instruction, the accumulator is loaded with the value 0. Okay. So after that we are writing the instruction means add A, then R5. So R5 means what is the content of the R5? Now it will be added with the value which is stored in the accumulator, and the result will be placed in the accumulator. After that, this instruction add A R7 means R7, what is the value stored in R7, that will be added with the value that is stored just the result we have obtained in the previous instruction. Okay, so R7 means the data which is stored inside the register R7 34. Now it will be added with the accumulator, and the result will be placed inside the accumulator. So after that instruction, the addition of 25 and 34, and the result will be stored inside the accumulator. Okay. After that, whenever the instruction add a 1 2 hex means the direct data, that will be added with the value which is stored in the accumulator, and the result, finally the result will be placed in the accumulator. Okay, so therefore it is simply the instruction which is written for addition of the 3 different bytes. Okay, after that, the last instruction, you see that as we have already learned in case of the microprocessor, there was one halt command was there, but here in case of the 8051, there is no such halt command, no such end command is there. What the command we are finding, actually it is the instruction is the pseudo instruction. Actually it is the directive of the software, org00 hex end. End means it is the software directives. Whatever the program we have written, what is the instruction it is written after end, that will not be executed. So it is the assembler directive. Okay, so the instruction that we are writing to actually to manage this situation is that here, then here is the level and SGM here. So after execution of this program, means after execution of the program, whenever my program counter is pointing this address 000A, then it is finding the instruction SGM here. It is 2 byte instruction. Therefore, SGM means the short jump. Short jump here means again it will come back to this location. So let us check what is happening inside the RAM address memory locations. Okay, so see that the top of this program, the table is given the list file which is generated after passing through the cross assembler. Okay, this list file provides us the column, the left hand side, the column where the ROM memory location where my machine code is placed, that is shown here. Okay, so it will be automatically generated by the cross assembler. Means what the memory location is blocked, why the opcode and operand, that is shown over here. Okay, so let us consider the first memory location, because the program counter is the reset value of the program counter is 0000. So it is indicating the first location 0000, and it is finding what is the instruction, that is move R5 then #25 hex, and opcode of this instruction is 70 and the operand is 25. So in this location 0000 hex, the opcode is stored like 70 is stored over there. Then in the next the consecutive memory location means 0001 hex, in this location my operand 25 will be loaded. Okay, so whenever the microcontroller is executing the second instruction, it is finding the instruction move R7 comma has 34 heads, means the opcode or the machine code for this one is the, here is the machine code given 7F then 3F. So 7F is the opcode which is loaded in the memory location 0002. After that the 34, that data will be stored inside the memory location 0003. Okay, so the next instruction will be executed like that. So move A comma has 0. So this machine code will be generated directly through the cross assembler. So we are just finding the data 74, means it is the opcode of this instruction 0004. In this location we are finding the opcode 74, and the 0005 location we are finding the operand, that is 00. Okay, so it is I mean, if we find from the top to bottom of this table, then we are finding the address location where the different opcode and the operands are placed. After that, whenever it is entering into this location, means the program counter is indicating this location 000A, so it is finding the instruction here, then SJump here. So in 000A location, the opcode it is finding, that is 80. 80 is the opcode for that SJump, and here means the relative address you have to provide it. So here the relative address is FE, means how to find that relative address, because the program counter is, if it is 2 byte instruction, so 80 is placed in the memory location 000A. After that 000B is loaded with the value FE, then the program counter will be indicating the location 000C. So if we are just writing the instruction here SJump here, that means it will direct the program counter to come back from 00C location to again come back to the 000A location 0A. So 0C plus FE. FE is actually the 2's complement of 2, because we shall generate the negative number 2 by using the 2's complement format. So 0C minus 2, actually we are adding 0C minus of minus 2. Minus 2 means it is the 2's complement. So it will be added with the 2's complement of 2. So the address will be calculated in this way, on this basis of this calculation, which is equal to your 0A. Okay, so 0A means it is nothing but the initial condition or the initial address of this instruction, wherever we are finding from the ROM memory location 000. So in this way you can manage this situation. So this concept was delivered in lecture, second lecture session, that is the stack and the bank 1 that is coincided. Okay, here the bank 1 which is the address of the bank 1 is from 0A to 0F. Now you see that the stack is also located over here. So whenever I'm just switching on my device, then you see that what is the critical situation that is arising. So stack is also a section of the RAM memory which is used by the CPU, but initially the stack is also located over here, because the reset value of the stack pointer is 07. Means whenever I'm just switching on my device, the stack pointer contains the value 07. So the first location means whenever it is executing the relevant instruction, then the RAM location 08 is the first location which will be utilized to be which will be considered to be as act as your stack by the 8051 microcontroller. So 8051 microcontroller will find that 08 location which is reserved for the register R0 which is coming from bank 1. So after another push instruction, means another the stack of related operation, then it will be incremented by 1. So stack will be incremented by 1. So 08 to 09, then 0A like that. So it will be incremented by 1. So that is the common conflict between the 8085 microprocessor and the 8051 microcontroller. So this concept was delivered in lesson 2. So whenever I'm trying to store my data inside the CPU register, then I shall push the data. Means SP means the stack pointer is pointing the last used location of the stack. Okay. So whenever any kind of this instruction is executed, means it will be incremented by 1. And whenever I am just retrieving the data, my instruction will be pop. So pop will retrieve the top of the memory location. So top of the stack will be retrieved first, and it will be copied in the register specified by the instruction. Okay. So how to remember it? This pop means pop and top. If you replace P with T, then it will be top. So pop means the top of the memory location or top of the stack location will be retrieved first. Now let us take a suitable examples to clarify it. So here the example one, we have shown over the sample program we have shown over here. So stack and the stack pointer from the following, we have to find what is the status of the stack and the stack pointer after executing these instructions. Okay. So we have written this instruction like move R6, then comma has 25x. Okay. So it will load 25 inside the register R6. So similarly, 1, 2 will be loaded inside the register R1 and 0 F3. 0 means it is actually F3. F means F is represented in hex. That is already discussed. 0 F3 means actually the F3 value we are loading inside the register R4. Now, the instruction which is associated with the stack is that push. So whenever I am pushing the data, means pushing the content of the registered R6 inside my stack. So initially, the stack pointer value of the stack pointer is 07. After that, whenever I'm just executing the instruction push 6, means actually I have to place the address of the register R6 because it will not directly access the register, name of the register. Yes, I cannot write push R6 directly. I cannot write push R1 directly. I cannot write push R4 directly. So what we have to do is that I have to write the address of the each and individual register. So push 6 means what is the value stored in R6 that will be loaded inside the stack. So after executing of the first instruction, means one by one instruction is executed and it is coming to the first push instruction, push 6. So therefore, what is the value stored in push 6? That will be loaded in value 08, means in the stack location 08, because the reset value of the stack pointer was 07. After the push instruction, it will be incremented by 1. Now it is pointing the address 08, and 08 will be loaded with the values 25. Okay. Now the stack pointer value is 08. And see that after executing the next instruction, push 1, what is the value stored in R1? That will be loaded in 09 location because the instruction push is executed. So stack pointer will be incremented by 1. So now the stack pointer value will be equal to 09 and 09 will be loaded with the value 12 because the R1 is containing the data 12. Then the other push instruction is executed then what is the value stored in R4 that will be loaded inside the memory location 0A. So F3 will be loaded in 0A because the stack pointer is incremented by 1 after execution of the push instruction 4. So after push 4, then 0 will be loaded with the value F3. So now the stack pointer is indicating the last memory location, which is 0A. Okay. So you can find that this is the common conflict of bank 1 and the stack because I have not assigned the register which is coming from the other banks. So by default, the banks are from the register bank 0. Okay. So you can see that this is register bank 1. So whatever the data we are storing over there, the bank 1, and actually the address is same, means what is the stack pointer is indicating, actually it is loaded over there. So it is common conflict between the bank 1 and bank 2. So how to remove this conflict, then it will be discussed. So now the stack pointer, you see that if I want to retrieve the data, then I shall, but the instruction I shall execute through the microcontroller 8051. You see that 3 instructions are there, pop 3, pop 5 and pop 2. Again, likewise the push instruction. Now the register is directly used with their name. So I can use the direct address to locate that this is the register R3. So I shall write here pop 3, pop 5 and pop 2. So pop 3 means it is actually the value which is stored inside the register. It is loaded, means it will, what is the value that is stored inside the stack that will be loaded in the register R3. Okay. So now let us check what they are. Say here in one, from this example, the stack pointer is say 0B. Okay. Because the stack location will be indicated by the stack pointer. Now the stack pointer is indicating this location 0B, where the value 54 was stored. Okay. So after execution of the pop instruction, means pop 3 means top of the stack location will be retrieved first. Pop, then top of the memory location will be retrieved first. So top memory location means this one. So 5-4 will be retrieved fast, and my stack pointer will be decremented by 1. So it is the common conflict between the microcontroller 8051 and many microprocessors. Whenever I am retrieving the data, then the pop operation is executed, then my stack pointer will be decremented by 1. So don't forget this concept. So after pop 3, what will be the next on the bottom of this 0B location, that is 0A. So it will be decremented by 1. Now it is indicating the next location, which is loaded with the value of 9. So whenever the pop 5 instruction is executed, then F9 value will be loaded in the register R5, and because the instruction itself is specifying the data will be retrieved inside the, and it will be loaded. What is the data is stored inside the stack, it will be loaded inside the register R5. Okay. Now this stack will be indicating the next point 09, and after execution of this pop instruction again, then the value that is stored inside the location 09 means 76, that will be loaded inside the value R2. Okay. Now the stack pointer will be decremented by 1, and finally the stack pointer will be 08. So 08 is loaded with this value because the instruction is already, and 3 instruction is already executed. So after pop 3, after pop 5, after pop 2, finally the stack pointer is equal to 08. Again, you see that it is considered with the RAM memory location where my bank 1 is residing. Okay. So I have to tactfully manage the stack pointers so that it will not create any conflict with the bank 1. And if I am executing instructions, several instructions like post instruction, one by one my pointer will be incremented. So it is coming to bank 1, then bank 2, bank 3, like that. So to avoid this conflict, what I have to do is that I have to use this stack pointer. Means stack pointer will be initialized with the other value from the memory location. Okay. So before executing the push instruction or the other instructions, I shall initialize my program with the value that is move sp comma has 5fx. Okay. 5fx means it is the value which is loaded inside the stack pointer, so that it will ensure that whenever the push instruction will be executed and it will be incremented by 1, so that the RAM memory location 60 will be the first stack location. Okay. So come to this point. So 60 will be the first memory location, this one. So 30 to 7F, it is actually the scratchpad memory location. So it will be used as your notepad. So we can use pencil and paper, just we are erasing it and we are writing something and we are erasing it. So this value, this location can be used as your stack. Okay. So if I can jump to this particular location whenever it is initializing the program and it is executed by the microcontroller, then the SP will be loaded with this one. Therefore, what is the stack location? Now it will be initialized, which is coming from the scratchpad RAM memory location from the overall 128 byte of the RAM memory location. Okay. Therefore, in this way, we can manage the conflict between the bank 1 and the stack. Now, we are writing the same instruction like R2, which is loaded with this one. R1 is loaded with this value 1, this one. Move R4, this is loaded with this value, this one. Then we are executing the instruction like that push 2, means what is the value stored in R2 that will be now loaded inside the stack. So initially, my stack pointer is loaded with the value 5F, means it is pointing the stack location and stack pointer value is 5F. So whenever the push instruction, first push instruction is executed, then the value will be, the stack pointer value will be 60. It will be incremented by 1, so it will be 60. So 60 is indicating the scratchpad memory location. This is the scratchpad memory location as indicating the first stack, first location of the stack. So the value 25 will be loaded inside the 60 memory location. Okay, so 6. So in 60 memory location, 25 is loaded after push 2 instruction. Okay. Similarly, for push 1 instruction, the stack pointer will be again incremented by 1. Now it is indicating this memory location 61. Again, it is coming from the scratchpad memory location, and my 1 to this value will be stored inside the register R1. Means what is the value stored in R1, that will be just loaded inside the memory location 61. So similarly, after push 4 instruction, my F3 will be loaded in the memory location 62, because the push instruction is executed, then stack pointer will be increased by 1. Now it is indicating the location 62. Now the value F3 will be loaded inside the stack. So this is the concept of stack and how to manage the stack. That is. So now, what is the summary of that discussion? That we have learned about the assembly level language, means how to write the assembly level language program, and what is the structure of the assembly level language program. That is also already discussed. And how to manage the stack in case of 8051, and how to write the program for the stack, and what is the main instruction used to, which is associated with the stack programming, that is discussed. So the addressing mode, the other part of the assembly level language programming technique, the prototype designing methodology, that will be discussed through the subsequent lessons. To get notification of the next lessons, so kindly share it, kindly like and subscribe my channel. Thank you everyone. Thank you for watching my video.